Hey all you cool sabers. Today, whoops, I do that every single time. I start a video and I immediately draw a line where I don't want it. Anyway, today we're going to take a look at what is called slope. So we've actually already talked a little bit about slope, but we didn't call it slope. We called it constant of variation. So I'm going to write AKA, and we're going to say COV, or constant of variation. Now I actually hate calling it constant of variation because it's not a constant. It was, you may remember from video 5.1, it was actually a coefficient. It should be called the coefficient of variation, but it's not. Anyway, you also will sometimes call it rate of change. Rate of change, and actually that is a much better description of what it is, but what we actually call it is the slope. Okay, so what is a slope? So this is a number which describes the direction and steepness of a line. A measure, whoa, that was messy. I'm gonna redo that a little bit. Let's see. Measure of, what did I say? I said it's the direction and steepness of a line. Direction and steepness of a line. All right. So I know what you're thinking. You're thinking, go on. So first of all, we need to know two things in order to calculate the slope. We need to know what's called the rise and what's called the run. So the rise is just the vertical change between 2 points, or a change in the y. So the vertical change in 2 points or change in y. The change in y. The run, not surprisingly, is exactly the same thing, except it's horizontal and x. So the horizontal, I don't know why I gotta zoom in so that you can actually read my writing when we're done. The horizontal change, I'm getting lazy. I don't know why I drew the 2. Or the change in x. So it's exactly the same thing, but with x, or the horizontal change. All right? And the reason this is important is because what the slope is actually, and we use m to denote slope. Why do you use m? I don't know. That's a really good question, but we do. We don't use s. Don't use s. Use m. But the way we calculate it is we just take the rise, or the change in y, and we divide it by the run, which is the change in x. So for this one right here, we got a ramp that rises 2.5 meters over 4 meters. So we would have 2.5. The rise, the change in the up-down change, and the side-to-side change on the bottom, so divided by 4, which gives us m equals 0.625. Okay? And there you go. So, what does that mean? So, that means for every, let's see, how am I going to word this? For the ramp rises, I should start with that. That's a much better way to start. The ramp rises 0.625 meters for every 1 meter of run. Okay, that's what that means. I mean, you could also have worded it as it rises 2.5 for every 4, but you know, that's confusing. Not that this isn't confusing, but anyway. So what we're going to do now is we're going to take a look at this graph here. Okay, this graph, you can't see where I'm pointing. I'm pointing at the graph. Okay, this guy, that thing. We're gonna take a look at that, and we're gonna split it up into these segments. We're gonna split it up from E to F, E to G, G to H, and I to J. So let's do in blue. Let's start with our E to G. So there is our line, and obviously, if this was on paper, we'd use a ruler and make that look perfect. But we don't have those things, so we didn't. So what we're gonna do is we're gonna say, well, we're going to turn this into a right-angled triangle just along the grid, and you're always going to do that. And that triangle can go on top, but we usually do on bottom, but it doesn't actually make a difference. All that matters is that if we look here, we see that we have a rise of 3. It goes up 1. From here to here is 1, to here is 2, to here is 3. So it goes up 3, and the same with the run. If we start at the E, it goes over 1, 2, whoops, oh my goodness, I don't even know what that, yeah, it goes to here, to here, to here for another 3. All right, so the rise is 3, the run, oh, I'm doing E, oh, I started with the wrong one. That's fine, we'll do, it doesn't matter. We'll do a rise of 3, a run of 3, which means the slope is 3 divided by 3, which just equals 1. So that's a slope of 1. The direction is up. And so what I mean by that is, as we read left to right, and you always read left to right. So a lot of times people get confused on this because they're like, well, what if I go from the right and go to the left? Well, you never do that. You always read left to right. So as we go in this direction, this line goes up. Okay? There we go. All right, so that's E to G. Now let's do E to F, since we were supposed to do that to start, and we'll use green this time. So I'll go like that. Okay, so that's my line. So I'm going to do the same thing where I'm going to make a 90-degree. I'm just going to turn it into a right-angled triangle right there. There's my right-angled triangle following exactly along the grid. So you can see we still have, our run is still 3. That hasn't changed. Okay. Our rise, however, we started here and we went 1, 2, 3, 4, 5. So it was 5. However, we went down. So we're actually going to call that a rise of -5. I don't even know what's happening here. Okay, that's a -5. So our rise is -5. Our run is still 3. So we're left with a slope of -5 over 3. Okay. Now, could you turn that into a decimal? Yes, you could. Should you do that? Not unless you're doing something with it. 99% of the time, you just want to leave your slope as a fraction. Okay. And the reason for that is just that it's easier to work with for the most part. The only time that you really want to do things as decimals is if it's like a word problem where you would never actually use, like if I'm saying what the speed of your car is, you're not going to say 5/3. You would actually say 1.67. Yeah. So anyway, this time you'll notice it's negative. It was going down this time. So our direction is, I probably wasn't supposed to tell you it was negative. That's going to be a reveal later on. Yeah, that's actually next. It's fine. That doesn't count as a spoiler. What's important is that as we read left to right, the line is going down that time. So let's take a look at G to H, which is a neat one. I'll do it in red. There's G, there's H. So my line, is going to go like that. Okay. So between those two, your rise is going to be 0. Okay, it doesn't go up at all. It only goes over. Oh my gosh, I keep hitting things. It only goes over 4. Okay, in which case our slope would be 0 over 4, which we do want to reduce that because it's just equal to 0. 0 divided by anything is just equal to 0. Okay, so the direction is horizontal, we'll say. Okay. Ooh, okay, and so that leaves us with our last one, I to J. I think I've only got one color left, so we'll use yellow. Okay, so there is, there we go. So, what's the rise? Well, this one went up 6, and it went over 0 this time. All right, so if we go to put that into our equation, we get 6 divided by 0, which doesn't equal anything. You can't divide by 0, so that's going to be, we're going to write that that is undefined. Okay, and so that's a vertical line. That is the messiest writing in the history of the planet. So anyway, so what's important here, basically, if we jump over here, you can see if we have a slope that goes up like this, a positive slope, because we always rise up a hill, okay, that's going to be a positive slope, okay, positive, that's the laziest way to write positive. I'll really write it. Oh, it's written right there. What am I talking about? I'm not writing it at all. All right. So that's a positive slope. If reading left to right, we go down, that's going to give us a negative slope. Okay. Now what you want to remember here too is that the number of steepness, the actual number itself, like ignoring whether it goes up or down, tells you how steep it is. A really steep line will have a really big number. Okay, so the way to remember that is that slope is a skiing term. The steeper the slope, you know, the more fun you're having. So the higher the slope, the more fun you're having. The smaller, the less fun you're having. And of course, if you are skiing and there's a 0 slope, which is a horizontal line, this is called cross-country skiing, and it is no fun at all. It is the worst thing ever. Okay, so if you've got horizontal, then it's going to be 0. If you've got vertical, you're not skiing if you're going vertically, you're just falling, in which case it's undefined, okay? It's not really, you're not skiing anymore, okay? Yeah, and so that's it. So, until next time, go Sabres.